What's up, everybody? Welcome back. Today we're working on our collaborative Rube Goldberg machine. And today's topic is trying to fix like high latency performance issues. So this is the project. We have this like simulation running, right? And each component of the simulation is kind of handled by its own WebAssembly module. So the idea is that like these platforms are not known by the real simulation. The global simulation just knows I have balls in chamber. The individual chamber then has some code inside it that says, okay, so if I want to render to this canvas, then like this is where I put the line, put pixels, and if a ball intersects with a platform in some way, I know how to like apply some sort of like physics impulse to it. And so that should be like a very powerful concept. We should be able to allow like anybody on the internet to just upload any chamber, right? We'll probably put some limits on them, like say like no excessive computation, no excessive size, no excessive memory usage, right? But like generally like outside of like performance problems, we shouldn't have like any concerns about just running arbitrary code because the WebAssembly sandbox should be pretty good, right? And so what this should allow is that like eventually we're going to let people log in with their Twitch account, upload modules, and we'll have some sort of like big simulation running on some server. Keep in mind that this is not a client-side simulation. It's client-side rendering, but the simulation is running on the server. So we have wasm on the server as well as part of our server-side code running again in the client. It's kind of like a fun little thing. Yeah, and so today's topic is trying to deal with the fact that if I am not sitting at the computer that's running the simulation, then it sucks ass, right? So this is me attempting to run the same thing on whatever server I rented from wherever. I don't know where this is located, to be honest. I haven't checked. But it's far enough that we're getting like maybe 50 milliseconds per like state request. Let's see if we can find like timings here. Yeah, we're getting like maybe like 50 milliseconds instead of less, right? And so if we're trying to run this thing at 60 FPS, we can't be over 16 milliseconds per frame. And so what we're doing right now is like really fucking stupid, right? Just like really dumb. We're basically saying every frame, let's just try to ask the server for what the latest and greatest is and then render it, which is like obviously not going to work well because you're like the frame rate is higher than like the network latency. Sorry, other way around. The frame time is lower than the network latency. And so the goal for today is try to figure out how to reduce that. And so what I wanted to look at is one thing that really bothers me about this thing is that like if we look at like the actual data that's coming in, we're wasting like a lot of bandwidth on something that's like really stupid, right? So we have these like 4-byte floats, and they're getting serialized as like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, like something like 19 or 20, right? These state arrays, so these are like basically when we render a chamber, the chamber on the server says, hey, this is where all my platforms are, and like here's just like a blob of data that I want you to send to the client, and like then give that blob back to me and I'll know where to put them, right? And so this should be like 1 byte long, this chamber state here, and instead it has like 2, right, which isn't so bad, but like here we're seeing like 2 to 3 bytes per byte, which is again just like silly. So I know that this isn't like the major cause. This is like almost unrelated, but it bothers me and I want to fix it. So I want to play with the idea of doing some form of like serialization, like binary serialization, and trying to import that back into JavaScript by basically like taking our serialization module, compiling it to wasm, sticking it in the browser, and then like feeding it data directly from the network. I think that'll be kind of fun. Then we can convert that into whatever format that like the browser needs to make that a JSON object. But then at least like this will get smaller. We could also like compress this stuff, but again, I just want to play with the idea. Something we use this stream as a excuse to play with ideas. More like the ideas are almost more important than the project themselves, right? So I think that that'll be fun to look at. So I want to look at it. Then I think that the actual fix to this problem is that we should batch our updates, right? So we should say, hey, I last rendered at like timestamp 10, and could you just give me all of the frames between like 10 and 20? And then we should like get that, and then when we get that, we can say, okay, I'll start the request for 20 to 30, but hopefully we won't like collide by then, and like maybe the client can like automatically figure out what like a good buffer length is. But yeah, we'll see how it goes. And then I wanted to look at maybe also if we like start running out of time from doing that, we're gonna have to like store those batches somewhere, and so it might be nice that since we're storing this stuff anyways, we might as well just kind of like drop it into a database so that when we restart the simulation, all of the like say our server crashes, it would be nice to be able to automatically pull up the last state and continue from it. So that's the plan. That's the plan. That is the plan. Is this simulation doing interpolations for positions? I don't know what you're asking because I don't know what I'm doing. But so there is no like client side prediction, if that's what you're asking. The server is basically saying like at 600 steps per second, we are going to take the position of a ball and move it by some velocity, and it is up to a chamber to decide if it wants to like use a continuous projection of that movement. Projection is probably the wrong word there. A continuous like the chamber, our physics library does have the concept of like if the ball goes across some line, then like move the ball back and apply the impulse here. Like our physics library does handle that, so that might be what you mean by interpolation. But it really, yeah, I'm not really sure. Like, I mean, in terms of like, it is discretizing these steps, right? He's saying like, I'm moving every step this amount, and then we just step frequently enough that it doesn't become like a major problem. But yeah, we'll see. Okay, let's try. Oops, wrong server. Let's try fuck JSON, because I think that will be fun. Okay, so I guess in our server, somewhere we get the simulation state. Simulation state. So this is used here, which creates one of these, which makes one of these. And it gets settled here. Okay, so we have this like simulation state serializer, which basically is like a wrapper for some types to make sure that like just like some holder of some state followed by some JSON stuff here. And so I guess we could just replace this, or not even replace, just add in a second function here that's like a pub function binary serialize, who's going to return probably like a slice of U8. Probably. That seems reasonable. Which means that he kind of needs like an allocator probably to make that thing. If it has to be super real-time WebSockets, I don't really believe that WebSockets are that much faster. I could be like a fucking dumbass. But like, if you just like long pull, like isn't that like the same thing? I guess like there's like a little bit of HTTP overhead, but how much is that really? Can't be that much, right? Like what? How much is in like a header here? Right, it's like 95 bytes on the response side. Sure, like our request header might be a little large, but like I don't think that like 900 bytes is gonna be like making, or like 500 bytes is gonna be making or breaking us here. But we'll see. I could be wrong. I just like I don't want to like pull up the complexity of WebAssembly into my server if I don't have to, because like I think that there's not trivial, and I think that they're still over HTTP actually. So if they're still over HTTP, then like how much bandwidth could we really be saving? I don't know. I'd have to look into it. Okay. So what is our like response expected to be? It's supposed to be a list of balls per chamber. Right. So we have two, and then a list of chamber states. We have chamber balls, chamber states. Chamber states is like the save data for each of our chambers, and the balls is a list of ball objects for each chamber. That makes sense. Categorized by chamber. Cool. WebSockets start as HTTP for compatibility but get upgraded. Oh, interesting. So they just turn into like a regular TCP socket later. That's kind of nice. That's kind of cool. Okay, so I guess we have to figure out how to serialize a ball. We have to like start at the lowest unit and work our way up. So what is in this thing? I think binary serialization is more interesting. I wonder if batching will be a bigger and easier win. I think it will be. I do think that. But we're doing it in the reverse order because we need to hold suspense for the stream, right? If we think that we're gonna get all of these things done in 2 hours, then if we get the fix at the beginning, then people will leave. But if we just hold on and say like, well, let's see how much this helps, and then we'll do the actual thing that we think will actually help. You kind of hold people's attention better, maybe. But now that I've told you that, maybe people will just leave because they think I'm manipulating them. That seems possible as well. Okay. So our ball is just 5 floats. I wonder if we can just like, can you just do like zig standard lib? Is there like just a put everything on the wire as like a bunch of LE32 like little Indian encoded things? Wouldn't you get similar effects to binary serialization if you put nginx/caddy with compression in front of your Zig server? Probably. Yeah, probably. Maybe. I don't know. I don't know how compressible. I can't imagine if we have like 32-bit floats. I find it hard to believe that putting those 32-bit floats into text and then compressing them will bring you back down to the same size. I think you can get close, but I find it hard to believe that you'd get like smaller. Maybe I'm wrong though. I guess there's some sort of like entropy. Like we kind of have like additional constraints where we know that our float is between like 0 and 1, and maybe the compression like accidentally takes advantage of that. That seems possible. But again, I am doing this part because I want to, more than because I think it's important. I also think it's like a thing, like a tool to have in the pocket. So I kind of want to explore it while we have the opportunity. I was looking for if there's like any way to like struct to like bytes, but with known encoding order. Like in std_mem, do they have like little native to little? Oh, so this is weird thing to be in mem, but do I have like LE? LE does not. That's gonna be hard to. Like, can I have like value as bytes, slices bytes? Yeah, okay. Oh, byte swap all fields. Swap the byte order of all of the members of the fields of a struct, which is probably recursive. So we could probably get away with like just taking the thing and slamming it into as bytes, but with bits like swapping byte order if we need to. But also, we know already that wasm and our server are both little Indian. So like really we don't really have to care about this. We can just comp time assert that we're little Indian. We already actually comp time assert like a specific ball layout. Because we just like put the balls into memory and then load them in wasm. So given that we're already asserting a ball layout, it kind of seems fine to just as bytes the ball. Okay. Which kind of makes it so that this first part of the request, like the inner layer here, is pretty straightforward, right? We can serialize a list of balls by just writing how many there are and then just dumping them in there. Assuming we get the alignment correct. Okay. Sure. So maybe let's start maybe by just making a ball list. I guess, yeah, let's maybe break the problem down. I like that. So maybe we'll just start with adding an endpoint in our server that we use for testing. So we'll just say like test binary serialization. Okay. I like that. Now I have to parse this URL, so we just come up. Test binary serialization turns into test binary serialization, and then wherever the fuck we handle all of these things, we can just do test binary serialization. Okay, and so what do we expect to happen here? Let's just start by sending one ball. One ball. How hard can that be? Right, so we'll look at the simulate app server app simulation balls items 0. Just kind of get right in there. And we know that we can do like as bytes for this thing. And we can even, yeah, it's fine, it's fine. So we start there. And he is going to give us a ball buff is this. And then let's just fucking slam that shit on the wire. So we say, hey, we are fucking ready to go. And we need like a content type. Is there like a content type user? Like if I don't have like content type of a standard thing, can I just make one up? Like what are the rules here? Content type, media type of the resource. In response, header provides the client with the actual content type of the returned content. The header's value may be ignored. For example, when browsers perform MIME sniffing, like can I actually like say like binary data? Like content type, binary data. Oh, binary octet stream? That sounds like what I want. Octet stream. Why octet? Okay. Is octet is 8? Oh, so 8 bits, 8-bit segment stream. Okay, sure. Yeah, okay. Works for me. Works for me, which means that we need to add this content type balls. Thank you. Very helpful. What do we call it? Octet stream. Dude, I worry that you guys are getting less intelligent by the day. It's kind of like the opposite of the intent that I wanted, like what I was trying to do by streaming not educational. This isn't educational content. Let's be clear. This is far from educational content. But I was hoping that people's intelligence might like increase watching this stream. That would be like nice. But it seems like you guys are getting dumber and dumber. Like the joke is degraded from making puns to just typing balls, which is, we'll get it. I guess that's fine. I guess can confirm getting dumber. Okay, so I guess we probably want to like copy this thing, probably, so that it like if it changes out from, well, it's not going to change out from under us. I guess like this writer will maybe like return on a boundary of a ball changing, and then the ball, like the values could like become inconsistent with themselves. So sure, we'll copy it out. Self server alloc dupe of a ball. We will duplicate the ball. It's simple. And then I guess we error defer that we need to free that thing. So we will free the ball buff. On you for doing something this ballsy. Yeah. You're right. It's on me. Ball buff when. Don't worry, I didn't miss the pun. That's a good one. Okay, so this should just send us one ball. And I guess we, on the other side, are going to need like some WebAssembly module in order to deserialize it. So maybe we make like source deserializer. Do I want this to be a capital D or a lowercase d? Is this a class or is it a bunch of functions? It's probably a bunch of functions. And this is going to have like some sort of exported function that says like, well, okay, first of all, I wanted to check, can you like create JS object from wasm? Like, I don't know if you can like incrementally make one of these things, or if it makes more sense to just like return JSON and let the browser figure it out. Data view. Set int32, blah, blah, blah. Can I be like, I want to like make a map? Tables? That's not really what I want. Like, can we like, fuck it. Can you create a JavaScript object from WebAssembly? Question mark. Blah, blah. Okay, let's see if he does something like that's like at all sane. Result object, result array, compute result, returns a result. Yeah, okay. Okay, so that's not. Oh, it has a length. That's kind of surprising. Where does that length come from? I mean, ChatGPT doesn't know what the fuck he's talking about, so we have to be careful here. Can I set properties on a JS object from a WebAssembly module if I want to return a map? What is this? I could JSON serialize the map and parse from JavaScript, but that seems silly. Define a structure in WebAssembly, pass the data from WebAssembly to JavaScript. Okay, that's so no. He's saying no, right? This is not what I asked, right? Yeah, it's okay. Yeah, so he's just saying no. He's just saying no. Which is kind of what I would have guessed. So say like going to JSON seems very silly, but is maybe fine. Maybe fine. Right, because like we're kind of more worried about like the network overhead than anything. Okay, let's do this. With the pattern that we've been using for everything that interacts with memory so far, is that we've been making like a variable in global space that's like JSON memory buff, right? And we say like, okay, here, you have maybe like, 16 kilobytes of space to work with. Then we want to take in some data. So our data is going to be like at some location, which is going to be like in data. And we basically say from JavaScript, we're going to like populate in data and export to JSON memory buff. I mean, you could use message pack. I could. I mean, but we'd have all the. What's the fun in that? what's the fun in that? Oh, you're saying I could use message pack and deserialize in message pack in JavaScript? But then I need to pull in some library. Unless like I don't message pack JavaScript browser implementing message pack. Yeah, like I don't want to pull in a library, right? I feel like the expense here is like not that high. It's fine. I want to try it. So we'll call this like, yeah, to JSON. Maybe. And can I like just export these? Can I like can I say that these are like global variables that I just want the WebAssembly to have access to? Maybe. Okay. So now what we want to, let's just say that this is like unimplemented for now, unreachable. And I want to just like compile this thing and see what it looks like. So we can go here, and the pattern that we've been doing a little bit of is we can build a WebAssembly module and then link it as a resource into our actual binary, right? So we have this like a generate embedded resources script. So we like basically like compile this thing as part of our build, and he constructs an array in Zig that has like a bunch of resources with imports. So if we look at like, let's see, probably it's in the Zig cache. We have a lot of spinny bar wasms in here. Is there somewhere here? So we like symlink all of the files that we want in our like to be embedded into our binary here, and then we construct this file that just like embed files these things left, right, and center, and then we can walk this array from our like main executable. So what I want to do is I want to add. We have an example of this of simulation wasm. This is like a client-side simulation. We can compile like another wasm module, shove it in these resources as part of the build, which is kind of fun. Kind of fun. So we just look at the simulation. This is our example. So we'll call this build deserializer wasm. And this is going to be from source deserializer zig. And we will return the emitted binary. That makes sense. That makes sense. Then whoever calls build client side sim can just do the same thing. Deserializer is equal to build deserializer wasm. And then we add that to our generated resource list. And then also for now, we're just going to also do like a install bin file. Add install bin file. What does this do? This creates a build step, which I guess we say like b get install step depend on b add install bin file with the deserializer wasm. I think this is what I want. I'm not 100% on this. Just return a pointer to an array. It's not so simple. It's not so simple. Is it like this? Deserializer step? Oops. Step? This? Like this maybe? Yeah. Okay, so it's fucked. Surprisingly. Oh, this should be deserializer. Let's fix all of these names. I think it should be fine, but I don't think that's why it crashed, but maybe. Shouldn't be. So I wonder where this is. This must be here. This like get install step must be causing problems. This is broken because of something. Stood meta from server at 447. No. Server zig 131. No. The fuck? What the fuck is going on? I mean, this must be related to the stuff that we just added, right? So can we like comment this out? Surely this is it, right? Oh, I know what it is. It's this. I'm trying to duplicate an array that is. Oh no, wait. This should be fine. Oh, this needs to be a U8 array probably. This as bytes returns an as bytes return type, which is a pointer. Oh, does this need to be an ampersand here? Probably. Yeah, there we go. And this has to be tried. Okay, okay. And now we can go back to looking at that deserializer thing, because that's what I was actually trying to do. So I wanted it to like end up out here so that I could look at it. But I couldn't figure out the like install situation here. Is it just like yeah, I mean here we did this with the lib physics, which is very similar. Get install step, add install artifact. So this is, we want add install bin file. Yeah, that comes from deserializer and goes to Maybe I'm not allowed to put the leading slash. Maybe this is what they want. Let's call this and see if we crash still. Right, we have to ignore the result. Fine. Fine, if that's what you want. If that's what you want, compiler, asshole. Okay, so now we should be able to do get install step depend on. I think I wasn't supposed to put a slash in front of deserializer. I'm pretty sure. This should be fine. Should be fine. Chillin'. Okay, so now we can go in here and we can look at our deserializer wasm. So we can look at wasm to watt, deserializer wasm, and we see, okay, so this is good. We do see our globals exported as well as our function to JSON. So this is interesting. Before we were exporting functions that would give memory addresses, but we can actually just look at the globals directly, which is pretty interesting. Pretty interesting. So I think now if we run our server, we should be able to go to like deserializer wasm and we should get something back, except that we're in the wrong directory. And we do get something back, which is good. Which means that we can start like writing some JavaScript now to try to pull and instantiate that thing. So maybe we'll write like a test. I guess we need a web page to go with this thing. So we'll make a little console log, hi, and then over here we will do like, what is it? Doc type HTML, head, body, and then here we have like script, source is equal to test.js, like this, I guess. And here we'll write hello world. Okay, so now if we go to test HTML, we see hello world, we see nothing in our console, which is surprising. I didn't save, refresh, hi, perfect. Perfect. Okay, so now here we want to do something like fetch from test, I forgot what we called it, binary serialization. So we want like async function in it calls await this. So we'll call this response. Response body is the data. And maybe we just console log the data first just to see what it looks like. He doesn't like this because network error, probably because our server's not running. He is running, but he's running an old version. Exporting arrays is neat. Did you have to set any flags in build or just our dynamic is true? I don't know. I just copy pasted what I had. So I don't really know what they look like either. So we'll see if they're actually useful in a second. We actually don't know. Oopsies, we need test HTML. That's where we're trying to go. Response body is not a function. Oh, fetch API get data. What is it called? It's JSON if I want JSON, but I don't want JSON. I want like fuck. Get data. It's not helpful. Oh, here we go. Blob or array buffer. Can I get the can I get it like streaming? I guess it doesn't matter yet. But I would like to like lazily shove it directly into WebAssembly memory if that's possible. But we'll start by just getting the array buffer. We'll start there. We have to start somewhere. Right, we have to await. Okay, so we do get a 20-byte thing. And how do I like see its data? array buffer. What the fuck is an array buffer? Array buffer. I can data view it, I guess. Yeah, okay. So new uint8 array of data. Oopsies, that's not what I want to do. I want to refresh. Okay, so that's some data, and we can try looking at what we get. So now we can try to like try to make some sort of like wasm module that's like await WebAssembly instantiate streaming. We'll probably look at an example here. So we have URL fetch URL, which is this, and no imports. Okay. And then we should just be able to like look at this thing. So we have a thing with instance exports with JSON memory buff. So what the fuck is a WebAssembly global? Like, what is this thing? He's just a pointer. Okay. That makes sense. So this is at 1064. I can't read that. It's so fucking small. Can I get bigger? No. Oh, yes. 106.4996 and 104.8612. So if we do like 104.8612 minus 106.4996, that's exactly 16384 bytes long, which is the size that we set for that buffer. So it does look like these are just pointers to WebAssembly memory. Okay, can we like, I want to see if we can like fetch data directly, what is it called? This is like, can I take the response body from fetch and put it directly into web? No, certainly not. Well, we'll see. He's just gonna tell me to like fucking copy it, right? Yeah, it's. I want to shut the fuck up. Okay. I want to get the body like one packet at a time or something. Like I want like instance memory buffer at that outset. Yeah, so I understand like the destination side. It's more like I'm trying to see like how do I like pull pieces of data from the body before it's ready. Get reader. This is what I was looking for. That's what I was looking for. So what is this thing? What is this thing? Get reader. So read returns a promise it resolves when a value has been received. So this is going to give me like some chunk, probably. Yeah, probably. So we can do like reader read then, and then they return more. So if I call then on a promise and it returns a new promise, it automatically queues that shit up. Dude, what is this syntax, by the way? They declare a function by name in these brackets and then reference it here? That's insane. That's crazy. Y'all JavaScript people are nuts. Okay. So I guess we want to do like append data. How would we like pull chunks of data in? I guess it's like it's almost like we want like an iterator of some form. I guess a function is fine. Function is fine. So we'll call this like append wasm data, and we'll say that we have like our index. Something like this. We have like some array that we're pushing into. It gets hoisted upwards. JS lives in its own world. Okay, if you say so. So we're gonna take in like our uint8 array, which is our like output, I guess. Where we are in the output, as well as like the input data. Okay, and then we can just do like output from like I onwards equal data. This is certainly not right, right? JavaScript fill copy uint8 array from to subset. I don't know. I don't know, man. This isn't what I want. Can I like copy from another one? How do I like uint8 array? Because like we could like slice the first one and then copy set. Here we go. Set. Yeah. So we do like output slice. Slice. Really? I could have sworn I saw the slice API on it. Let's do this. We'll start by getting the wasm in data is obj instance exports in data. This is a new uint8 array using obj instance exports memory. And we know that it's 16384 long, which is kind of like we're cheating. We probably shouldn't do that. We might want to put this size somewhere in exported memory as well. So we could do like in data size. That seems kind of reasonable. Actually, for now, we'll put a fix me. Export size. And then let's like console log in data. Just so I can get a feel for like how to fucking work with this thing. Missing name after dog. Fuck off. Okay, comment out this thing. Okay, that's not good. What the fuck? Did I type something wrong? Probably did. Instance. Obj instance exports in data value, of course. And this is memory buffer if I remember correctly. Okay, this is better. So we have a bunch of zeros. Wonderful. And now let's do something like, I guess we can look at this thing and look at its prototype. So I think it has like slice, yeah. So we slice and then set. Fill. Nah, that's not what we want. Copy within? Ooh, what's copy within? Oh, that's like within itself. I see. That's within itself. Not what I want. Where the fuck was I? Was I over here? Here we go. Yeah, so I guess it is just set. Okay. Let's look at the arguments of set as well. Fuck. This one. Here. So we can set the target offset. The offset into the target array at which to begin writing values from the source array. Okay, so we want to do like append data is like output.set data I. right? Something like this. Then we're gonna get this reader, and where the fuck was our example? This wasn't it. Was it here? Reader? No. Readable stream. This is it. Reader, read, then. Append wasm data. And then here they're saying that we return the reader. Oh, so maybe we do like a something like this. So append wasm data to the in data 0. This takes in, what was it? It was like done and value or something. So in data 0 value. How do we get like our index? Oh, he just puts it outside. Okay. Var I is equal to 0, I guess. And then we put I here. If done, return. Otherwise, we return this thing again. But we can't call this because we didn't give it a name. Fuck my life. So this bullshit is like actually kind of like required. That's insane. That's insane. So we just have to do this like inline function bullshit. That's crazy. It's crazy. I guess like you could like attach it to a class with some state. You could do like class data writer who's got like a constructor. He's got like this dot I is equal to 0. And then he has like this output is equal to output. And then in here you could do like async append done value. And then you get all this stuff. Which feels nicer, to be honest. Feels nicer. So we just have like this output set with value offset by this I plus equals value length. That feels nice. And then if done, we return. Else we return. I guess we need like a reader in here as well, huh? And then we do something like reader read, then this append. Bind this. Is this how you write JavaScript, guys? Then here, say this reader is equal to reader, and then here we say this reader read, then this append bind this. I think that you're not supposed to use bind anymore. I'm like fucking like what, like 15 years out of date or something. But maybe this will work, which is really all I want. Okay, so now we just do like a new I think we want like start here, where we do this first. Does this like get bound? No, we almost want like, I feel like the way I want to think about this is not the way that they've structured it. We could do it like this. We could do this. We could do let response is equal to this reader read. Then response dot done, probably. Let's do this. Let's start here. This feels like it's going to make more sense. Yeah. This is going to make way more sense. This is going to make way more sense. Return. Fuck this. fuck whatever they told me to do. I'm gonna do what I want to do. So we're gonna say const writer is equal to a new data writer with output and reader. And then we can just do like await writer run. That feels better to me. That feels so much better. Okay. Value not defined at 9. Cool. Value not defined. That makes a lot of sense. So we got a promise here. Makes sense. Right, so we just have a done and value fields. Okay, this makes a lot more sense. Okay, so we could say like, if response done, we return. This all goes in a loop. And hopefully like their like async system is smart enough to like not fucking hot loop this. And then here we just say this output set, this value, and this doesn't even have to be a class anymore. This just could be an async function. Wow, they should have fucking told me to do this. This makes way more fucking sense. Way more sense. Holy shit. Consume reader. I'll call this. Boom. Wow, wow, look at that. We're so smart. Let's go. Okay, so while true, we call reader read. We say offset equals 0. We store this as offset. And then offset plus equals value length. This is now just output directly. Wow. Very easy. Very easy. So this is just going to be like consume reader with the in data as where we're sending it and the reader as the thing we're consuming. And then now we can probably look at where were we logging the in data here. We'll log in data again here afterwards. And we should see that the in data is like full of our shit, but instead we see value is not defined. That's annoying. Probably because this has to be response dot value. Value is not defined. Fuck off. We missed one. We missed one. Can't convert undefined to object at test.js 7. Oh my god. You can go further and do use for await let x of reader read Jesus. Even if that's true, I'm not going to do it because I'm going to get confused. But appreciate it. Appreciate it. So what's it pissed about here? Refresh. So this is set. This is set. This is set. So what's the fucking bitch about? Cannot convert undefined to an object. Test.js 7. Oh, is it that value? This is only, we can only do this if we're not done. Is that why? Okay. So now we should see 20 bytes of shit in here. Which we do. We did it. Guys, we did it. It just took like fucking an hour, but we fucking got some data. Fuck. Okay. So now we have that data in JavaScript land. And we should just be able to like, once we consume that reader, we should be able to call like obj instance exports to JSON, right? And then we should be able to look at the output data. So we should, after we call that, be able to look at like obj instance exports and whatever the fuck we called it, JSON memory buff. And this should return a length, I guess. So we'll call this like JSON len is this, and then we're going to look at the output data here. This is going to like JSON encoded version of the thing. And this is going to come from JSON memory buff value, and he's going to go for however long we returned. Then we're going to look at like a text decoder. and it's like decode JSON encoded. Do I have to put this in braces? Maybe. Okay, let's just like see if that does something. If here we return, let's just first start by setting, we'll ignore the actual input data and we'll say JSON memory buff 0 is equal to this, and 1 is equal to this, and we will return length 2. And let's just see if we get like an empty object returned to us. So I think we have to build again so that this gets like embedded in the binary correctly. Because like this is getting compiled and then shoved into our web server somewhere. Obj.instance is undefined. Fuck you. What do you mean? At 37. Oh, because I spelled instance wrong? Ah, my life is so hard. Okay, that's good. We did get our curly braces back, which means that we are interacting with the memory the way we expect to. So now we can get crazy. I guess we want like the in length here. Right, so consume reader must tell us the offset. Okay, then we have the in length is this, and we call to JSON with the in length. And then in here, we're gonna look at in data 0 to in length, and we're gonna expect that this is a ball. So we're gonna look at, I guess we will import physics, which is where the ball lives. And we go stood mem. We need stood. Stood mem from as bytes as value, I guess, is gonna be a ball. And then we just fucking stood JSON stringify the value of ball, and with options of I don't know, nothing. And we're gonna pass in a reader or a writer, I guess. So outstream, and the outstream needs to be like var outstream is equal stood mem fixed IO fixed buffer stream around JSON memory buff. And then here we probably need like writer or something. And then here, does this return like the output length? No. So I guess we need like a counting. Counted stream is a stood IO counting writer around outstream writer. Outstream.pause, oh, it just already exists. Nice. Okay, maybe. Maybe. Let's see how that builds. Of course it doesn't. Invalid type given to fixed buffer stream, so I need to put a little ampersand on him probably. Oh yeah, that all works. Okay. Let's just see what happens. Oh, no fucking way. No fucking way. That actually worked. Cool. And so now what? I guess we wanted to turn this into like a JSON object. So we're gonna call this like JSON parse. And then can we like do this in like a loop and do it a few times to see if we see the object's position changing? Let's just log like ball pause. And let's just do this like while true. I think this while true should be okay because there's awaits. So those awaits will like trigger not just fucking hot looping, hopefully. Oh yeah, that's pretty fucking sick. Pretty sick. And these values are like same, right? That's what I really wanted to know. They're between 0 and 1, and they're like kind of moving kind of like proportional to like they're like moving like in a direction relative to their previous value, right? So it's not just like all over the place. We're probably doing the right thing here. Okay, so that is step 1. Step 2 is to maybe get a list of these things, right? So we want many balls now. And so how do we do that? I think we are going to just kind of write them all. So slice as bytes. We can then write out this whole slice. And I guess we probably want to write down how many of them there are. I know in this exact scenario, we can infer how many there are by the size of the array. But I know that as soon as there are multiple things, this is going to be a problem. So we can say that like num balls is, well, so I guess instead of just getting this like ball buffer now, we actually want to like write into some things. We're going to like do like output is a std array list of U8, right? And we're going to say like, if this fails, we're going to clear this thing. But until then, we can do this. So we're going to start by append slice, and we're going to append the slice of a U32. So we're going to say const num items is a U32 is equal to this shit, right? And we'll just say what std math cast this or else. And this probably has to take in the type here, so we can actually say that we don't have to write the type here, we can just write it here. And here we'll return error invalid, or like internal error. Alt F4, thanks to the raid. What's up, you guys? For those of you who are new here, or those of you who are not new here, just for those of you who are, can we click this? We are working on our Rube Goldberg machine. So the idea is there are balls, they move through chambers, right? These chambers are defined by WebAssembly modules, and the idea is that like the global simulation doesn't know that these like things exist, right? So like these platforms that are moving back and forth, the simulation doesn't know about them. All it knows is that it's calling a WebAssembly module and saying like, hey, WebAssembly module, I'm giving you like a list of balls that are in your coordinate frame. And could you tell me if you need to do something to them? So the WebAssembly module goes like, oh yeah, I just noticed that the ball hit the platform, and so like, could you like punch it up a little bit? And the server goes like, okay, I'll do that next frame. Chill. The reason that we want to do this with WebAssembly modules is because we want like super customizable behavior, right? So you can imagine that like somebody could write like, you could do something like, maybe you're like simulating Mario versus Donkey Kong and the balls like roll down these hills and you want to write like a little AI, so you have like a little guy in here and he tries to like jump over the balls or something. And that's like one of the chambers. Maybe another chamber is like you have like a black hole and like you have like balls orbiting this thing getting like flung out. Maybe you have one that's like, you have like portals and like the ball falls in a portal and like it's like shot out another one or something, right? Like we want to be able to do basically anything that we can imagine within the constraints of it being like 2D and being like, I guess I shouldn't say anything, but we want to be like extremely flexible, right? So we support anything that you can write in code to apply physics operations on these balls. And people, like once this is ready, the idea is that people will be able to upload WebAssembly modules and we will just run them. And so that's kind of like the concept of like the whole project. Right now we are working on, we're kind of like on a side quest where if this is, how to say this? The way it is set up is you have like server, right? And the server is doing like physics. Then you have like client, and the client is basically like render, right? And so like since these two things are not happening in the same place, the client now has to ask the server like, hey, what do I render now, please? And he's basically doing this like once per frame, and it's really fucking slow. And So we are working on we're on like a side quest from this side quest where uh it's kind of silly that like the thing that we're sending back is this like JSON blob, but the JSON blob is taking these like 4 byte floats and turning them into like 20 byte floats and taking our like 4 byte 1 byte state of like wasm things, wasm chambers. They have like state saving and loading. It's turning like each byte into 4 bytes. It's just like silly. So I wanted to play with the idea of like encoding this in like a binary format and then decoding in a wasm module. We're playing around with that idea. I don't think that's the real fix to this like slow. The fact that this is like slow as shit is we need to like batch our requests, right? Because we're polling like once per frame, and it like means that if our latency is like 50 milliseconds, we can't render it faster than 50 milliseconds. So the real fix is to batch stuff. But before we get there, I wanted to play around with like binary serialization. So that's what we're working on right now. That is what we're working on right now. So that's why you see us doing something silly like taking these balls, just like dumping them on the wire as like memory, which we know that we can do. We have like some assertions in our code that says like in our wasm machine as well as on the server side, we have like asserted that the ball layout is exactly the same in memory. So this is like totally safe. And then we are prepending this with some numbers. So I guess we want like append slice, which is going to be stood mem slice or value as bytes. This is going to be num items like this. Boom. This is going to be try, and then we're going to, instead of duping here, try output.append this thing. Okay, chillin'. Then this needs to take, at the end here, we say output slice is output byte to owned slice. Perfect. Then we take the output slice len here and feed it into our HTTP writer over here, and he'll free the memory when he's done. Okay. So what is next? Now on our decoder side, now we're kind of like writing these things like in different places, but the intent of this deserializer being like a Zig module that's compiled to WebAssembly is that like the serializer and deserializer will eventually live like right next to each other, and the intent is that like maybe we can get away with like some sort of like intelligent like just metaprogramming or something, or like at the very least like just having them live next to each other is nice instead of having to write it in different languages and stuff. So it's a little silly, but we want to play with the idea. Maybe we'll find out at the end of the stream that we hate it and we'll never do it again. But that would be a good learning experience. Okay, so he needs to look first. He needs to consume the first 4 bytes of this thing. So we'll say in data from like 0 to 4 is the num elms. So this is going to be stood mem bytes as value, and we can actually just say the C32 like this. And then we say that balls is just going to be stood mem bytes as slice of ball from in data 4 to num elms times size of ball, probably plus 4. Then we have our like balls output, and we can just say, could you fucking serialize our balls, please? Maybe. In length is not used here, so we need to ensure that the balls length is like less than this. But for now, we'll just discard it because fuck it. Fix me. Clearly, we can go out of bounds. Okay, so if we do this, I guess we want to run over here. Fuck! It's always broken. U32 and comp time int incompatible types. Okay, can we just like as usize here or something? Is that gonna like fucking figure this out? No. Unexpected type usize found. Oh, do I need to? Fuck. Oh, it's other window. This probably has to be like dereference. Oh, probably actually just want to dereference this thing directly here, which will turn this into a U32. And then do the type sign up. It's actually on the server side. So the decompiler or deserializer is working okay, compiling okay, I should say. But we fucked up this code here, so this is append slice. Course. And then expected blah 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 280. Am I high? Maybe this is not supposed to be an ampersand. Probably. Okay, so we can now run our shit again and just see how broken it is. Where's our Firefox? Here we go. Where's our test? Here it is. Refresh. Lots of undefined, which is super cool. This is just not getting set. Super cool. Surprising. Surprising. So what are we doing wrong here? So we get the output, we append the 4 bytes at the front for the size, then whatever is left. Then we take that thing, we write it. So if we look at the like network traffic here, we should run our server actually, of course. Enter. Okay, so we look at the network traffic. We should see like some garbage in here, which is great. That is what we want to see. We do see some garbage. And so the fact that this is all undefined is surprising. Okay. So this not working. But can we look at maybe at the release, like did we get some reasonable data? So we can look at in data. We can log this every frame, fuck it. Calling it frames is a little silly, but you know what I mean. Okay, so here we are clearly seeing that we have data, that we have, 5 bytes or 5 elements plus some extra shit on the end. Isn't it a slice of ball not ball? Should ball be balls in JS? This is just. Oh, you think that like if I look at this as balls and just log all the balls? Yeah, you're smart. Thank you. So these are super valid now. We can see that the radius is 0.25 on all of them, which is correct. Okay, so we've made it a little bit farther. Okay, so what is the next thing to do? The next thing to do is to try to like work our way up to like the whole simulation state. So we were looking at the server and we were looking at the simulation state serializer. He gives back the balls, which we now could do. And now we just have to tack on the saves at the end. So maybe what we do is just for each save, we just say the length of the save and tack on the rest. Yeah. So we'll do something like for self server app simulations chambers, gross. Probably dot items. Yeah. We have a chamber to look at. And each chamber, we're gonna save that chamber with our allocator. This is something that can fail, and then we'll say slice is this, or save we'll call it. Defer, error defer, just defer, save.dnit for real. Because we're gonna copy it out, so it's fine. Free save. So we unconditionally free this thing. And then before we get rid of him though, we say output append slice save. And we're also going to append a single byte. Ooh, we'll make him a 4 byte, fuck it. It's a little wasted space, but I don't care. I guess I do care. So a lot of these things are going to be like 0 length. In which case, like, maybe we want to store, but maybe what we'll do is we'll say we append the save, then first we append the length. If save len is equal to 0, we do nothing. Otherwise, we append. I'm thinking. The length as a U8. Here we'll just say like if save len is greater than 255, return error, internal error. I don't think that it should ever be bigger than 255. We can increase this limit later. It's just something to test with. We can int cast this as a U8. It's going to be save len. Okay. And then we will just append the save. Yeah. And we will also append the chamber ID. Chamber index. Plus chamber IDX. And here we append chamber IDX as well. And we'll just say here if chamber index is larger than 255, then we have a fucking problem. But this will be fine for now. Okay, so now a lot of these guys will be empty. We have 1 extra byte for the save length, 1 extra byte for the chamber ID, and then the actual bytes. So if the thing returns 4 bytes, we're going to serialize as 6 bytes. Maybe that's not great. The other option is that we just take a 1 byte hit for every empty buffer. Maybe that's like not even worse. So maybe we do that. Just say, fuck it. We allow zeros. Yeah, sure. That works for me. So on the deserializer side, now we should say that we like expect there to be some sort of like, while true, our index is going to be like balls end is going to be this. And we call this here balls end. And then we can do like index is equal to balls end. Okay. IDX. I guess this is while IDX is less than in length. We do IDX plus equal, or we look at the thing. So we say save len is equal to the in data at index. Then we increase the index. And then we increase the index by save len. And we say save is equal to just in data from IDX to IDX plus save len. Yeah, that seems right. Simple. And I wonder if it makes sense for us to kind of like lazily JSON this stuff. How do I say this? So maybe we'll do like, we have like a writer based around this outstream, right? And we say like before we do the balls, we say like JSON writer begin object. And we add a key, or what is it? It's like a field. Yeah, object field. And we say we're looking at the chamber balls. This is just balls right now. Then we just write balls. Okay, then we are ready to do like object field saves, chamber save, whatever, it doesn't really matter right now. And the saves we are going to, for each save we get, just JSON writer write save. Yeah, simple. Simple. Okay. Then we just write the output stream position. Now we probably want to wrap this with something that's like, with a version that's failable. Just because all of these like JSON stuff can like fail, and I don't want to have to write like the same catch thing over and over again. So we can just write try everywhere here. Okay. And then here we can call like to JSON failable within length, and return this. Otherwise, return 0. Shouldn't they be arrays? Yeah, you're right. So here we want to begin an array. Here we want to end an array. Here we want to end the object as well. And then each save, we write the save, which is already an array. So chill in there. Chill in there. I mean, it's not guaranteed that this doesn't work. There's like a chance. There's a chance. It probably doesn't compile. It never compiles. So write stream expected 2 arguments. So I think we just need like some like dummy arguments here. No member error on stringify? What the fuck? Oh, does this need to be like writer here probably? And then this needs to be var matey. Okay, now we're back in server side. So these guys need tries on them. Okay, maybe. Let's take a look, skis. Let's take a little look, skis. Wow, I did not oh, saves length 0. That's not good. That's not good. So we did get the balls out. And why are we not seeing saves? It would be kind of nice. Ah, fuck off. Stop. Can I pause the scroll back, please? Oh my god, stop. I don't care. How do I fucking pause? Fuck. How do I pause the fucking... Oh my god. So we kind of expect that at byte position like 24, 25, we start seeing saves. No, we don't expect that. Fuck, it's fucking... So here we say that we have 5 balls, so we expect 5 times 20 is 100. So at 104, we want to start seeing data. And then we do just see zeros, huh? So it actually is that there are no saves. Is it possible that we just have no save data? But we should at least see that we had 3 chambers with 0 length saves. So there's something wrong still. Clearly something wrong. Okay. So all of this... Can we look at like saving well, we should be able to tell how many items we have by just going to the main page. So we have 4 chambers, and we know that this chamber has some data in it. So we should be getting an array of 4 there. We're not. Okay. So how do we fuck up? So while index is less than save length, we try to write this array. So it looks pretty likely that this is just never being run. Let's say we like shove an unreachable in there and just see if it still works. Because if it still works, then that means that we have fuck off. That means we have a fucking problem. Yeah, so the fact that it's still working there indicates a real problem there. It's that balls IDX is not less than in length at ball's end. So maybe we can look at on the JavaScript side. Can we log in length here? Let's take a little peek skis. So he's seeing a 104 length thing. So that's kind of indicating that like we are not writing this, which is kind of surprising to me. Brett, like, oops, stood debug, print, writing, save. Oh, I'm a dumbass. That's why. This is down here. We are like altering the thing after we're done with it, which is fucking stupid. Oopies. Oopies, oopies, oopies. There we go. That unreachable is now executed, which is good for us. So now we can just remove that unreachable and see if we get saves. Bump, 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 okay, wait. That's sick. So we do see saves, and we see one save with 20 bytes, one save with 2, and two saves with nothing, which is like actually exactly what we expect. Because if we look at which these things are, there's the platform positions in here, which is 20 bytes plus I think there's like a time step value in here. And then maybe there are directions as well. So 5 times 4 is 20. And then this is like a single byte, which is how many balls are in the chamber. So, and then these two have no data associated with them. So that's actually really good. That's really good. Okay, the last piece. Last piece is we are serializing the balls directly instead of the chamber balls. So in our original thing, we break down the balls by chamber. So we need to do something like, let's think. I guess we write out how many chambers there are. So we'll say const num chambers is this, which we're not going to look at balls, we're going to look at chambers. Okay. Num chambers. Then what? Then what? We're going to write that thing. Right? Then we immediately start writing the balls for each chamber. So we're going to say for 0 to num, I guess we're going to do for there's like a simulation get chamber balls. Here we go. Given some allocator and some chamber ID. Okay. So this is going to be chamber balls. And then we're going to do this for each one. So for 0 to this thing, because apparently for loops need to be U sizes, we learned today, which I should have known at some point before today. But, you know, you live, you learn. We just append ball data. So it's just instead of this being here, we're going to look at chamber balls items at adjusted balls. He doesn't like that because maybe this has to be try. And this probably needs a D in it as well. This needs to be variable for that D in it to work. Makes sense. Okay, that compiles. So now we have we start with number of chambers as a U32. Then for each chamber we start with the number of balls in the chamber. Then we get the balls. Then we have the saves. So that should actually be everything that we had before in the original. Deserializer. So now we just have to adjust this a little bit. So on this side, we have num chambers. So this becomes num chambers. And then we kind of start index here at position 4. And then we say while or for 0 to num chambers int cast like this, maybe something like whatever, doesn't really matter. Doesn't matter. We need to look at maybe there's nothing to worry about there. And we're gonna kind of here get the number of elements is going to start at IDX and we'll end at IDX plus 4. Then we're gonna write out some stuff. We're gonna get the balls for that section. And this is going to be like, I guess we do IDX plus equals 4. And then we will say the end is this. And we're going to go from 0 to balls end. Nice. Now this is going to get written to our JSON stream. So I think this was supposed to be called chamber balls. And I guess each iteration of this thing, we're going to start a new array. And then end an array. And then here we're going to write the balls. And that's maybe it. Maybe we're just good to go here. It's possible. It's possible. I should also probably look at, there was like a memory leak somewhere, and we should fix that. Fuck. This needs to be a U size here. Did we increment IDX here? IDX plus equal balls len here. Then we come back around. Should be good. Should be good. Should be good. Where's our test? Fuck! Unreachable. Unreachable. And there's no way of knowing. I guess here we were supposed to put all of these in one big ass array. And it's possible that the JSON writer is angry at us because we started an array where we shouldn't have. It was worth a shot. Okay, I guess we start, we just start if true, returning. And maybe we want to get a little fancy with it. So here we'll say end array, end object. So this should be fine. Fuck. Return outstream pause. Okay. Okay, yeah, so that just gives us an empty array, which is kind of what we expect. Then we go down here and we just bisect a little bit. So we bisect a little. I'm pretty sure this will just be fucking broken. It is broken, like it is reasonable. So it is something in the code that we added is broken. Shocker. Shocker. Okay, can we like break after one iteration? Let's see what that looks like. Okay, so if we break after one iteration, we do in fact get a ball, but that ball is corrupted as fuck, right? So we fucked up kind of immediately. So we get the node chambers from 0 to 4. Can we maybe say, well, we know that immediately after the first chamber, it's already fucked up. What is the if true block for? It just makes sure that like Zig gets mad if you like return and then have stuff after, because he goes like, that's unreachable code. Like you shouldn't have that there. And so the if true just tricks it into like thinking that this stuff below could still happen. Okay, IDX starts at 4. We look at in data. Can we just let's do this. JSON writer write num elms and then break. So this should give us the number of balls in our simulation as the value in the balls array. Let's just kind of see what that looks like. That's actually immediately also giving us unreachable. That's surprising to me. So this isn't even working? Oh, we need maybe it's because of this. Maybe we need to end the array or else it gets angry. It's possible. Yeah, okay. So now the thing we got in here is 5. It thinks that there are 5 balls, which is good for us. That is what we expect. And our in length is 145, which I think is also... I'm actually not sure here. Okay, so this parsing, okay. Good to know. Now we say num elms times the size of the ball. Oh. Oopsies. Oopsies. Okay, so let's try this again. So we go back to what we think should work. We should get one sane set of balls here. That's funny every time. So you have chamber balls 1, which is an array of 5 balls. They all have different radiuses though, which is a problem. So this is still bugged. Still bugged. Still bugged. I guess there's like a chance that we fucked up on the input data side. That's like very possible. So we could look at test.js. Here, we should probably log the in data. Just so we can take a look at it. Okay. So this is saying that there are 4 chambers. And the first, fuck. Oh my god, fuck off, dude. Let me fucking pause scroll back. Holy shit. Okay, 4 chambers, then 5 balls in this chamber, which immediately is followed by another 5, which feels wrong. Are we writing the number of balls every iteration or something? So we start with the number of chambers. Okay. Then for each chamber, we get the number of items, of the number of balls in simulation. This is fucking wrong. This should be chamber balls len. Ah, that was probably it. So we were saying that there are 5 balls and every chamber has 5 balls, which is just untrue. Okay, so now we have 0 balls in this first one, which is maybe correct. That's maybe correct. Let's go back to our deserializer and get rid of some of these hacks. Okay, now let's try. We should see all of the balls now. All 5 of them should be spread across 4 arrays of which chambers. Fuck! It never works. Can we do like, can we get 2 chambers? I just want to see like some amount of progress. Looks like something somewhat sane. Okay, so we do get 2 arrays, and one of these arrays does in fact have a ball in it, and this ball is the correct radius, which is a good sign for us. This is a very good sign for us. So how many of these can we put up with before it starts giving us unreachables? 3 is no good. 2 is no good. So why would that be? Oh, this index is wrong. That's why. This should be index is equal to balls n, because that's like the number of balls, not their byte size. Oopies. Oopies. It's a hard life. Unreachable still executed, surprisingly. Oh, because I have plus equal to here instead of just equals? I think that's it. Fuck. Unused capture. Unused capture. There we go. There we go. Quick, we need to pause so that I don't get angry in a second. And so we have the right amount of balls with the right data in them. Hell yeah, baby. Hell yeah. Okay. Okay. So now we should actually be able to like swap everything out. I think we have everything we need to be able to like return the binary data instead of the simulation data. So we should be able to like integrate this into like the real app. Chamber saves or chamber balls. And I think the other thing was supposed to be called chamber saves. And we should be able to go into our like test.js and basically take this stuff and put it into our like main thing. So we'll call this like, I guess we just put it here. Maybe we'll make a function for it. Get simulation state. And this is kind of everything in here. Now we're gonna like call this thing. We're gonna say like, I guess we just store the deserializer somewhere. Call this, yeah, we'll call this obj, fuck it. Okay. So now we're gonna have to call get simulation state from somewhere. So on initialization, we can maybe create our deserializer and pass him into our chamber registry, which is where all of our chambers are pulled from. We kind of store this thing here. And we say this deserializer is equal to deserializer. Boom. Then on relayout, no, on render, yeah, we say get simulation state with this deserializer. And then we call this simulation state. We comment out all this shit. Fuck this noise. We've got better binary data now. You can't whatever. I don't know, man. I have nothing to nothing to say. Okay, let's just kind of see what happens if we do this. There's like a non-zero chance that this works. I would say probably still close to 0, but not totally 0. Fuck. Consumer window is not defined. That would do it. Probably we should run this in another window so that we can edit our JavaScript without having to recompile and re-embed all of our shit in the same app again. Wrong fucking thing. So chamber states is undefined. We named it the wrong thing. We call it chamber saves. This is chamber states. But there's a chance. There's a chance this works. Refresh. Chamber states is undefined. Simulation state, chamber states is undefined, but we just defined it. Can we disable cache is disabled? I guess we should probably print out the thing we get, huh? Probably. So we should maybe console log balls, which is not balls. Really? What the fuck is going on? Do we need to like hard refresh? Oh, here we go. Chamber balls, chamber states. Simulation state dot chamber states is undefined. That's this word, right? C-H-A-M-B-E-R, C-H-A-M-B-E-R, S-T-A-T-E-S, S-T-A-T-E-S. Okay. So we're on the right track, but maybe we forgot to type in await somewhere. That seems likely. Yeah, this is a promise. This should say await. Still no bueno. So this is at index.js 130, 132. Can we like, wait, we did log the simulation state. Okay, chamber.render. So this is coming in at, can we just like pause on this like fuck up? Like, okay, so what is it complaining about? Where the fuck am I? What is happening? What is happening? Can we just set a breakpoint on like render ball pause is not defined? We just like set a breakpoint here. Hello? Why are you fucking so laggy? Fuck. Oh, interesting. Wait. The chambers are rendering now. To some extent. That feels different. Okay, so why is ball is like an array for some reason? So chamber balls. Oh, there's like a double nested array that maybe there shouldn't be. Probably in our loop, we're writing an array here, but the thing is already an array, so it'll be turned into an array itself when we write this. So I think we just had a double nested array when we shouldn't have. Oh, there we go. To some extent, this is broken. Odd. But I wonder why that's broken. This is surprising to me. Because, like, I bet you if we look at the data right now, it's going to be hard to find. I'm a better programmer than you. That's rude. I wouldn't go up to people and say that. Like, or say anything kind of along those lines. Like, it kind of just makes you an asshole. Right? Like, maybe, but you know what, you can do what you want and maybe people won't like you, which is fine. It's just that's crazy. I don't even care if it's true or not. Okay. What was I trying to... Also, I don't really care at all. Even if you are a better programmer, that's great. I'm sure that's great. It's just a weird thing to say. Okay, so why the fuck is this state not updated? Like, I'm expecting to see 001 here somewhere. So we could maybe kind of figure out, this is chamber ID 2, and we could look at the state that is trying to be fed into chamber ID 2. So we could look maybe wherever we try to load this shit. Here. We could try to look at what the save is. So we can look at and one of these things we're expecting to see like a 1 byte array that has the number of balls in this chamber. That's what we're hoping to see here. But instead, I fucking typed the wrong word here. Fuck! Why is it broken now? Did that console log break it? Or is it because the log, like, why is this so slow? Very strange. Oh, maybe because I'm just like fucking flooding with other console logs. So let's try to like delete those a little bit. Does Nix come with the taskbar? Let's see, how do I say this? Nix has the ability to use whatever desktop environment you want, and you can set the configuration to install KDE Plasma, which has a taskbar. But I don't know if that's what you're asking. I think like Nix, you know, the operating system doesn't really have a desktop environment. You get to pick one. It's kind of how it works. I don't understand. There's something weird going on here where it's like inconsistent. But at least now it's kind of running. So maybe what like the trick here, there might be a race somewhere that I kind of fucked up. I might have forgot to type a weight somewhere. But it's okay. For now, let's go back to where what we were trying to debug was the save state, not making it back. So it was in load chamber. We were trying to log if chamber state length. Can we like, maybe let's just start with logging chamber state length. I expect this to be an array, but maybe it's not. But it is. Okay. And we are seeing one of them of size 1, which is good. And we can even maybe say if chamber state length equals 1, triple equals, can we just like console log chamber state at 0? Because in that case, we should be seeing this number, like the number that this is expected, which is the number of balls in the chamber. So can we like refresh and just see? Fuck. Can I like, how do I like say that this is an int? 0 plus? That seems like the JavaScript bullshit that would coerce things into an integer. Like, just if I had to guess, I would guess that that does it, even though it's fucking stupid. No, it stringizes it because the right says a string. How do I like how do I get like the byte value of a thing in a string? JavaScript get ASCII value of character, I guess is kind of along the lines of what I want. Car code at. It's possible. It's kind of fucking annoying, but maybe. Maybe. Can we, so this, I don't know why this doesn't work if I have the console open when I start, but okay, so this does look like it might be the right number, right? I'm seeing 1 here when a new ball comes in, so this should go to 5 now. Yeah, so the number, the save state is getting, we have the data that we want. It just might be associated with the wrong chamber. That's a possibility. So can we maybe see load chamber? We get the chamber states from this ID. And okay. I'm thinking. So how do I know? This is, we expect the chamber ID to be 2. 0, 1, 2. So we're expecting 2 here. So let's kind of see if that lines up. Can we just like console log console log. Oh, this doesn't have to be async, by the way. That might be related, but probably not. We're gonna say chamber is this ID. Let's just see if that gives us a clue. Okay, so we are actually seeing this associated with the correct chamber as well, huh? 0, 1, 2. So I don't really understand why that's not working. It could be that the format of the state is unexpected now. What's going on in here? So we load chamber. We just try to set the data to chamber state. Can we maybe look at array here? If array, oh, we could maybe check here. If chamber state length equals 1, we should assert. Is there an assert in this language? No. Abort, right? That's how you. If array length is not equal to 1, then this is a fucking problem. That's how this works. So even that is working as expected. So it could be that like maybe it's the fact that this is a string now instead of an array. Can I ask? Oh, hold on. I think I know what it is. In my deserializer here, I need to make sure that we never fucking write this thing as a string. I think that just like fucks stuff up. I think here I want to write like emit strings array false or true. Just like fuck it. Always make it an array. We got assert, import assert from node assert. Fuck, you're in the browser. I'm so dumb. It's okay. It happens. Y'all JavaScript people have to keep track of a lot of stuff, I will say. It seems like so hard. There we go. We're back, baby. We're so back. Okay, so we did all of that work. It took way longer than I thought it would. As usual, it always takes way fucking longer than I thought it would. And what we can do is maybe commit this. Let's maybe also disable the linter script because pushing is going to be fucking slow. So can we just say like return here? Cool. And then let's add -u, get commit -m smiley face. And oh fuck, not fast forward. That's probably okay. I'm just gonna force it and then fucking smack myself in the face. What? Oh, that's fine. We have it tries to clone the repo to do some like linter script stuff when I push. And I'll just have to let that happen because it like, yeah, it's fine. It's fine. It sucks that the submodule, I have the submodule pointing to GitHub, so my machine isn't just like, oh, I already have that. So it has to like reclone from GitHub every time I push, which is like fucking stupid. I should probably fix that. But I don't really know how. I guess I would like mirror wasm time locally just to avoid this. Ugh. Blah. Gross. And then while this is running, we can SSH into our remote box, and we can see if this did anything. My bet is that it didn't. My bet is that it's what's going on here? Git log. So I have git support any server URL. Git log origin whip. Is that in here? That's in here. So we can just check out origin whip, I guess, and then zig build. Okay, so my bet is that it's gonna still be slow as shit. But it was a fun experiment either way. Remember, guys, the real something is the friends you made along the way. What's it? The real prize is the friends you made along the way. That's kind of our view of this. We'll see. Failed to check, cause spinny bar. Fuck off. Git log. Let me revert this. Git status. Okay. we forgot to actually add the spinny bar to the Git files when we were doing that pre-stream, so it's fucked. This server is $2 a month, so these builds are not fast. But the fact that we can build it, oh, we didn't add the deserializer, fuck. Add source deserializer, git commit -m smiley face, and then git push origin whip, and we have to wait for it to fucking clone again. Can I disable this lint script? I probably can. Let's go to git. We look at our ball machine hooks, and we'll just kind of like update back. There we go. Now it's not going to try to do any work for us. Much better. Okay, can we git commit -m smiley face? And fuck, we can't. Git config fuck. Git stash. Git pull. Git log? Where am I? Git checkout origin whip. Git log. Git stash pop. There we go. What is the reason for all this git sorcery? I'm just like trying to get the code onto the server, man. But then like the fucking code is like not in a good state, so we just have to like we're kind of massaging it a little bit because we committed some absolute garbage. Git pull. I mean, we're not checked out to like a normal branch because there was like diverging branches because I fucking force push all the time and I don't know what I've done over here, so I don't want to lose it, you know. Okay. I expect that this is gonna be Garbo. And it sure is still absolute trash. We were at like around like on the order of 50 milliseconds before. Oh, we did lose like maybe 10 milliseconds. Or maybe it's luck of the draw. Maybe she's born with it. You know, but there's a chance. No, we're back up at 50 milliseconds. I think we've probably just kind of gained nothing. Let's like, I wonder if we can, I mean, you could do like real benchmarking, or we could click a little bit and try to like guess how the average time. I don't think we get anything. I'm pretty sure we didn't get anything. So that was a fun little. Are these all separate TCP connections? Yeah, I know. It's because I think there was something busted with our HTTP server and connection reuse. Oh, it's that it actually slows down when we reuse connections because of the fucking stupid shit we're doing. So when Firefox is allowed to just like rip as many connections as it wants, it'll do 6. But if we tell it that we can reuse connections, it will just wait. We don't do like what is it called? HTTP pipelining. HTTP pipelining. Yeah. So we just don't do this, right? So Firefox kind of expects that he can like rip 3 requests for us, and we'll process them in parallel. But instead, we just don't do that, and we do what is similar to this thing on the left, and then we're just really fucking slow. So if he tries to reuse connections, he'll actually do less in parallel because he thinks that we should be pipelining when we're not, if that makes sense. So that's why we don't. You do TCP reuse. But okay, I mean, this was a fun little exercise, and it's kind of fun to know that it had literally no effect for the problem that we're trying to solve. What a fun little. Oh, that's kind of fun. What a fun little exercise. But I think we had fun. The idea of like, what the fuck is going on here? Is it fucking? Oh, that's why this got set wrong somehow. Much better. Yeah, I think it was fun. I think the idea of like taking some data from the network and shoving it directly into a. Oh, that was me. I deserve that. This is supposed to be locked behind an admin panel, but it's not right now, and so this was expected. And yeah. What can I say? So I think the idea of like taking some data from the network and shoving it directly into a WebAssembly buffer and then like processing that data in some way. I think that that's going to be like very useful as like a tool for me to have in the future anyway. So I'm not really like upset that I spent that time there. But it's clearly not the right answer. So I think the right answer is going to be to uh, basically buffer like many frames of data at once. And we'll see how that goes another time. So we'll call it there. We made no progress, but we had some fun. Thanks for watching, you guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours for the main stream. These streams get archived on YouTube under like playlists. So if you want to go check those out, there's a link in the Twitch description, as well as the code for these things ends up on GitHub. So if you want to check that out, that's available as well. What else? We're doing this like pre-stream thing, so probably from around like 12:30 Pacific time to around 2 Pacific time. We kind of cover like today is not so much, but a lot of times we leave a lot of garbage lying around and like there's some cleanup to do, so we kind of do stuff like that. Today pre-stream we were working on like just a random module that we might want to add in here. There's all sorts of stuff that we, anything that's not like someone spamming the reset button, I deserve that. I'll take that off screen. Basically things that like don't fit into like a nice 2-hour block of focused work feature development, that kind of thing will be happening on like pre-stream. So if you want to check that out, I go live at like around 12:30. Those streams get archived to Patreon, which is linked in Twitch and YouTube if you want to throw money at me for whatever reason. Don't know why you would, but if you want to. What else? Like, subscribe, Twitch Prime, and let's say goodbye to YouTube and Twitch. Let's find someone to raid.